Imagine building a payment service and hard coding a particular payment gateway, let's say like Stripe, to that particular payment gateway. Now, if your company further wants you to swap to a different service or make a modular multi-payment gateway system, how do you deal with that? Congratulations! Now you have to rewrite the entire payment service. No, that's not what you should do. That is really messy. Uh, Actually, in while making the whole payment service in the first place, you have to decide that are there going to be multiple payment gateways or not. Based on that, you decide the architecture. And if you just simply modify this particular code that you have written for Stripe to for PayPal, you're breaking an important principle among the solid principles, that is the open close principle, which says that a function or a class is open to extension but closed to modification. And we are clearly modifying the code here, right? And that is not recommended at all. So how do you deal with this situation? How do you build such a payment gateway that you can maybe switch to a different payment service later on? Now, to deeply understand the solution, we should actually beforehand understand the problem even better. Because until you don't understand the sense of the problem, the solution won't make much sense. So I prepared a mini code base to understand the whole problem and the solution. So let's head on to the code base to understand it better. So I have written this tiny router that charges through Stripe only, as it says. So also the payment router name goes charge single hard-coded provider. That means we are hard-coding the provider here. So let's get into this function and understand it. In this charge Stripe only function, it is actually a pretty simple function. We are just returning the response. But imagine it being the standard implementation of the Stripe gateway. Now, if we want to process the payment here through PayPal, let's say we want to swap the payment gateway to PayPal, how would we go about it? First of all, you would change the payment gateway, right? Let's swap it to PayPal, and let's imagine this being the function that we call for the payment gateway. So it might take some different parameters. Let's say it takes something called extra, and it is a string, let's say extra for some reason. Yeah, even in the metadata we can also have multiple parameters, param or something called, depends on the PayPal payload, I don't know. Okay, so it could demand anything from you from the code, right? So we'll have to update all the modification, all the change. We have to do all the changes for the according to the PayPal gateway. Also, we'll be required to update the function name, right? We'll do it. We'll call it PayPal, and we'll update the doc strings as well. So PayPal, right? So we've essentially updated some stuff within this function. We are modifying, as I said, we are modifying this function, and right where we call this function, we'll also have to change it to PayPal, because else it will throw error. So I'll just copy the name and paste it here. Now see, it's asking me to import this change as well. So I'll have to change the name here. So with just these tiny changes, you are modifying a whole different flow, right? So that becomes problematic, because you'll have to test it again, you'll have to look for bugs, and it becomes more messy. So how do we fix this? So the fix, before understanding the fix even further, we should reimagine the problem itself. So now instead of swapping, let's actually make a multi-route payment gateway, because if we make a multi-route payment gateway, we'll be able to define the solution for this problem as well. So imagine we are building something like this. The user calls the server and chooses the particular payment gateway, and the server switches it at runtime. So the server will decide at runtime which payment gateway to call. Okay, so how can we actually make this, and why will this become the solution? We'll come to that later, but let's for now decide how to implement this. Okay, so again to the code base. I have another a tiny little route that I have written here. It says charge with hard coded gateways. Now here the payment provider was hard coded, but here the gateways are hard coded. Let's go into the function to understand. If you see the implementation of this function, I have basically created a conditional based switching of the payment gateways. If the string gateway string says Stripe, we go to the Stripe route, else the PayPal or the Razorpay route, and you know for Just Pay maybe. And if nothing works out, we'll just throw an error, right? But even this is not a proper solution. This is actually a very bad implementation of what we want to do. That is, make this multi-route payment gateway work, right? Why is this messy? Let's understand first. First of all, the code is really getting bulkier. The function is getting bulkier. Now, if we implement the Just Pay implementation as well, it will get even bigger. And let's say we want to add a new payment gateway now. For example, we want Paytm payment gateway. So we'll do something like Paytm, right? Now we have a Paytm payment gateway as well. But is this a good approach to do it? No, of course not. We are still modifying. The problem remains the same. We still have to modify the code that will, cause bugs and cause issues in our system, which we'll have to debug later or deal with later. So, how do we actually deal with this situation? For this, we have to understand something called as the strategy pattern. Now, what is strategy pattern? Strategy pattern is a low-level design pattern that helps us, switch to a different function or different implementation at runtime. Let's understand it deeper. Take this example. Imagine you know how to drive a car. Okay, so we have this car object or a car class which has these functions, called steer, accelerate, press brakes, shift gears, all that stuff. Now, if some person or you know how to drive a car, now it doesn't matter if the car is a Honda car or a BMW car. You know how to drive, right? So let's say for these two cars, we have implemented. It works like basic inheritance. We have implemented a Honda car. We've extended Honda car through the car class, and we have implemented the BMW class from the car class as well. Now, they might have some differences internally, how they steer, how they accelerate, how they shift gears. Maybe they have different type of gears. The internal implementation of their functions does not matter, right? Because in the shift gears, Honda might have just 5 gears, and BMW might have 6 gears, and we can shift accordingly, right? We don't need to know the implementation within the functions, as long as we know that the function is present there, right? We can shift gears. We know how to use gears, how to steer, accelerate, and all that stuff. Okay, so now we have a function called start drive, okay, which basically starts driving the car. We pass on a car object, and it automatically shifts gears, accelerates, and steers, and all that stuff. Okay, so doesn't matter if we pass BMW car in it or the Honda car in it, it will behave the same, right? Because both of them have the same functions. They might have some additional functions apart from these, but that doesn't matter to our start drive function, right? They might have them for some different reasons, right? So whatever we pass within this class, be it a Honda car or a BMW car, it will behave the same, it will work the same. This is the essence behind how strategy patterns work. We define different strategies. Here, the different strategies represent the Honda is one type of strategy and BMW is the another strategy. Now we can actively swap between these strategies. So we have a main function where we can, keep swapping these strategies, and it will keep on behaving differently based on, what object we are passing. And this is what we, traditionally call runtime polymorphism. And with strategy pattern, it becomes way easier to make these swaps happen without making the code messy. Now, now that we understand how this strategy pattern is implemented at the very base level, let's see it in action in the real code base that I have created. Okay, so we were here so far understanding how the bad implementation went. Now let's understand the actual good implementation. So there are two routes this time that I've created. One that sends out the different gateways to the user, that gives them the option, like we have the Stripe gateway, we have PayPal gateway, we have Razorpay gateway. You can choose whatever you want, right? So then we have the main, function that charges a user the amount based on the payment gateway they have chosen. Now, how does that work? How does this whole thing work? You can see we have something called as the charge function, which is coming out of the checkout object. Checkout object is dependency injected using checkout service dependency. So, and at the end we are just returning the response. Now let's get deeper into the dependencies. How are they behaving? So first of all, let's go to this charge function to understand the implementation. We are passing the amount in cents, because let's assume this is a US based company or something. We have a currency as USD and a some reference passed. So let's go into the charge function. It is way simple to understand. It's just that we have created a checkout service where it takes in a payment gateway while creating the service as the first parameter. In the constructor we take the gateway, as the argument. Payment, we know the payment gateway, and we simply call the charge function that must be present in the payment gateway. It's as simple as the example I gave you here, that a car had a steer function. So we can call the steer function either it be Honda or it be BMW. It is the same situation. The payment gateway could be any payment gateway. It could be Razorpay, PayPal, Stripe, whatever. All of them must have a charge function, and as long as it has a charge function and takes the same arguments, it will work relentlessly, right? So if I go to this charge function precisely, you can see that we have come to something called as the payment gateway strategy. So this is the base class, just like we had the car class here. This is the base class called payment gateway strategy. Now it does not have any implementation, so we'll have to implement it. So we can define different payment gateways here. We have a different gateway for Stripe, which is a charge function, as I said. Each one of them must have a charge function with the same number of arguments and the same number of types and all. Now internal implementation doesn't matter. It's their responsibility to handle however they want it, because each code base behaves differently. With each payment gateway comes its own constraints. So internal implementation doesn't matter as long as the outer structure, the abstraction, is the same. So for the Stripe gateway, we have a charge function with the same parameters and types. We do something and the payment is done. Same for PayPal, same for Razorpay, and whatever we want. Now we have created something called a gateway factory. Factory is nothing but we can. How do we pick a strategy? That's what factory does. It will help us pick a particular strategy, generate a strategy for us. It has all the classes. We'll just give it the Stripe key. It will give us the Stripe gateway class as the value. It's as simple as that. So yeah. So we have some more functions like create gateway. It does not actually create the gateways. It just uses this gateway factory, and this is a factory function basically. This is another whole different what do you call, a design pattern. It is called the factory design pattern at the most basic level. So what it does is it takes a keyword, let's say Stripe or PayPal or whatever. Based on that, it will give out the class. It takes the key and gives out the class. And if it is not present in the factory, it will just throw an error. Else it will return the particular class. Now resolve gateway from request. This function takes takes the payment gateway string from the header. Whatever we pass in here as the key is resolved from this particular function. It extracts the header called payment gateway from the request headers and pass it on to create gateway right here, which generates a gateway factory and returns back the factory. And that's how the whole flow works seamlessly. Now if you check out this particular checkout service dependency, it is an annotated way of calling get checkout service. This function is getting called basically and annotated to this type. So if I go to this function, which is right here, it takes a payment gateway via get payment gateway strategy. function, which is another dependency function, and returns the checkout service that we just discussed. Okay, so it basically creates an object for this checkout service and also passes in the payment gateway at runtime. So get payment gateway strategy, if you go here, it calls the resolve gateway from request that we had seen earlier. It takes from the header and all that stuff. So that is how it works. Like, in a basic implementation, we have done so much. The code base remains concise. We are swapping at runtime. We are, uh, it is very simple now. It has made lives easier. And yeah, so now if we come back to this problem, that we have actually created this multi-route payment gateway, right? That we can choose at runtime which payment gateway we want. Perfect. Now, what about the earlier problem, the first problem that we had? We don't want a multi-payment gateway. Let's say we don't want the multi-payment gateway. We just want a single payment gateway. It's just that we might want to, in the future, swap it with a different payment gateway. That's it. Now, instead of having these many, instead of choosing a particular strategy, we can just have a single strategy which we might make additions to. Like, we have these many strategies here. Let's say we just want Stripe for now. We'll just keep a Stripe gateway. We don't want the rest of them, right? We can just delete them. Okay, so we don't want them. We just want the Stripe gateway, and we know everything works smooth. But if later we want to introduce other payment gateways, we can simply create other implementations. We can extend, not modify. That's the open close principle as well, right? We are extending the implementation, not modifying it, and that will help us outgrow the payment service in a different way. If you later want to make it a multi-payment gateway service as well, it is flexible to that too. So that is what strategy pattern really is. It helps us switch strategies at runtime, switch to different implementations of something. It is basically runtime polymorphism. I would urge you to go out and read about strategy patterns and factory patterns, and there are more such design patterns that are really, really beautiful. And once you learn to implement them, you will see code like puzzle pieces. You'll know what puzzle pieces to create and what puzzle pieces to connect, and you will write way better code. And about the strategy pattern, it does not just implement two payment gateways, it implements two DB routers as well. DBs, or database routers, or caches. It is not necessary that it is a payment gateway. It could be MySQL, for example. We could be the server calling MySQL, but the company later decides we don't want MySQL, we rather want Postgre. So now, instead of creating the whole config once again, we can just simply swap from MySQL to Postgres. Simple. And even in some cases where we can do the same thing to databases as well. Just like have a multi-route database. We can have multiple read replicas or maybe multiple shards to a database, and that's where again we can create a similar DB router to this using the strategy pattern. So it's extremely useful and extremely helpful, and it will again help you become a better engineer and crack your interviews as well. Okay, so that was it from my side. I hope you have understood what the strategy pattern is, how it applies to real world scenarios, and I hope you will create your own strategy patterns and share in the comments. So yeah, thank you so much, and don't forget to follow me on Twitter. You'll find it in my bio, and I'll add it to the description as well. Okay, so till next time, bye bye.